What's up, my dear developers? How are you doing? In the last episode, we added a game over panel to the game, and in this episode, we will make the game robust by enabling the game to pause when you go to the home screen or the Activity Apps Overview menu. The first thing I'd like us to do is to get some understanding of the current robustness of the game by investigating what happens when we hit any of the menu buttons. And when doing this investigation, it's really helpful to see what messages are logged by the system, so we can click the Logcat tab and make the window a bit bigger. Then we launch the app and start experimenting. We start by pressing the square button to open the app's overview, and what happens here is that the app crashes, and we can read in the Logcat terminal that we get an Android runtime error saying fatal exception in thread 2. And if we continue to read further down, we see that the error is a Java lang null pointer exception that arises from an attempt to invoke virtual method void android.graphics.canvas.drawColor on a null object reference. And if we read the three last red lines of the error message, we understand that it's the surface view.draw method that is responsible for the error. On the next line, we see that it's the game.draw method on line 113 that causes this error, and on the last red error line, we see that it's the gameloop.run method on line 59 that is the root cause for this whole error tree. We can follow the links to the errors to remind ourselves of what the code actually looks like, and we start by going to game.java on line 113. Here we see that the method super.draw is called from the draw method inside of the game class. And if we go back to the Logcat terminal and follow the link to the gameloop.java line 59, we see that the game's draw method is called inside of the while loop, which actually defines our whole game loop. So just to recap, the game loop is inside of the run method, which is the method that will run when the underlying thread in the game loop class is started, and we call the gameloop.startLoop method when we want to start the thread. We will leave the analysis here and come back to it later. Now we will try and see what happens when we click the circle button to go to the home screen. Once again, the app crashes and we actually get the same error message as before. You can see that it's an Android runtime error saying fatal exception in thread 2, and it's caused by a null pointer exception, whatever that is. Let's run the app again, and now we click on the triangle icon to get back to the previous activity or state. Once more, we get the same error and we have no idea how to solve this problem, so we have to do some more debugging to understand the background mechanisms of the surface view. Let's start from the assumption that we know nothing about how the surface view class works, and the only thing we know is that we have some override methods called draw, surface destroyed, surface changed, and surface created. If we look at the surface created method, we see that we start the game loop when the surface has been created by calling gameloop.startLoop. We don't do anything specific when the surface is changed, and we don't do anything when the surface is destroyed. And already here we can intuitively guess that the surface is needed in order for us to be able to draw something to the screen. And probably when the surface is destroyed, we would have a hard time drawing something to the surface, which could maybe be the source to our problem when the app crashes. But since we cannot be sure how these methods work, a good way to find out would be to log some messages to the Logcat terminal to understand in what order these methods are called, so we can find some patterns in our errors. To log a message, we can use the log class by writing log.d for debug and pass in two strings as argument, where the first string is a tag that can be used for filtering the Logcat terminal output, and the second string is for displaying the actual message we want to print. We will put the name of this class as tag and write the name of the method as message. And we also make sure to log before executing any other code in the method, since then, if the code gives rise to any errors, we would actually not be able to see the message. Now we can copy the logging statement and paste it in all other Surface methods and just change the messages to the corresponding method names. And now it's time to once more examine what happens when we click all the different menu buttons. We start the app and can now see in the logcat that we get a debug message from the game.java class saying surface created, and then another one saying surface changed. Now we waited quite a bit, so the game over text is already showing, but that doesn't impact our investigation, so it doesn't matter. We click the square to get the app's overview menu, and we can now see that we get the message surface destroyed, and after that we get the same error as usual. So now our hypothesis has been confirmed, and it seems as though we are not allowed to call the draw method when the surface has been destroyed, since it doesn't exist anymore, which gives rise to this null pointer exception. We can also quickly check what happens when we click the circle button to go to the home screen, and yes, we get the same sequence of actions as for the app menu, so that's good. We also checked for the triangle button, and it's once more the same sequence. The conclusion we can draw from all these experiments is that we can solve all of our problems if we find a way of stopping the game loop from calling the draw method on the surface holder just before it's destroyed. But how can we know when the surface destroyed method is about to get called and pause the game loop just before? Well, we would need to know what method is calling the surface destroyed method, and also how to stop the game loop from that method before the surface is destroyed. Since I have some, although quite limited background knowledge about how apps work, I strongly suspect that the information we need can be found by studying the life cycle of an Android activity. So let's Google Android activity life cycle and select the link Understanding the Activity Life Cycle. The first paragraph reads, as a user navigates through, out of, and back to your app, the activity instance in your app transition through different states in their life cycle. The activity class provides a number of callbacks that allow the activity to know that a state has changed, that the system is creating, stopping or resuming an activity, or destroying the process in which the activity resides. If we scroll down a bit, we'll find a section called Activity Lifecycle Concepts, and the text here reads, to navigate transitions between stages of an activity lifecycle, the activity class provides a core set of 6 callbacks: on create, on start, on resume, on pause, on stop, and on destroy. The system invokes each of these callbacks as an activity enters a new state. This means that all activity state altering actions that a user does will trigger one or more of these 6 callbacks, and we can be quite confident that the menu actions that we issue will trigger a sequence of these method calls. So our mission now is to understand in which of these methods we need to stop the game loop to avoid calling the draw method after the surface holder's surface has been destroyed. First, we will just open the activity life cycle diagram in GIMP and try to understand the flow of the different callbacks. When the activity is running, the next transition is triggered when another activity comes into the foreground, such as when we click on one of the menu buttons and the onPause method is then called. When the onPause method has been called, there are 3 different possible transitions in the flowchart, and the first one is when the user returns to the activity. This could for instance happen if you have multiple activities in your app and you switch focus to the other activity and then switch back to the first activity. After returning to the first activity, the onResume method is called and we once more end up in the state activity running. The second flow we could have is when another activity comes into the foreground and the onPause method is called, but the activity is no longer visible. Then we end up calling the onStop method. This could happen when we click the home screen button and we no longer see the app's activity. And here, if the user navigates back to the activity, we call the onRestart method, followed by the onStart method and onResume method, and once more end up in the state activity running. The third and fourth flows we could have is when another activity comes into the foreground and the onPause method is called, followed by the activity is no longer visible, and optionally the onStop method is called. This time an app with high priority needs RAM memory, which leads to the app process getting killed. So pay attention here that this could happen either directly after calling the pause method, for instance in the case when another activity in the same app comes into the foreground, or it could happen after the onStop method when another app is in the foreground. To get the activity running again, the user needs to navigate to the activity, and from this state we first call the onCreate method. Something worth mentioning is that it's usually in the onCreate method that the layout of the activity is set, and in our case we initialize our game class in the onCreate call. Then the onStart method is called, followed by onResume, and we come back to the state activity running. The fifth case to consider is when the app has been paused and stopped, and then the activity is finished or being destroyed by the system, which results in a call to the onDestroy method and the activity shuts down. This could be the result of having, let's say, an activity for showing a help section in the game, and when the activity is not used anymore, the activity is destroyed. Or it could simply be that the whole app is terminated. Now, after going through all the different flows, I hope you have a better understanding of how an activity works. I know it's a bit much to take in all at once, but don't worry, we will do some experimenting now and make sure that we understand when and in what order the different callback methods are called. We can start by opening the main activity class and make a split screen between the activity lifecycle page and Android Studio. Here we can see that we already have the onCreate method, where we set the content view to the game class, where we do the updating and drawing of our game. And what we can do now to understand the activity lifecycle workflow is to simply override all activity callback methods and print some logging messages in each of them. So we will just look at the list of callbacks and override them one by one. We begin by hitting Ctrl+O for override to get up a menu of all methods in this class that can be overridden, and we type onStart and then hit enter. Then I personally think it's easier to just copy and paste this method 4 times and then just rewrite the names of the methods as well as the call to the super methods. Here I just look at the right side of the screen and write all the method names that you see under the Activity Lifecycle Concepts section. When all the methods are overridden, we can add some logging, which is easiest done by copying the logging code we have in the game.java class and then paste it as the first statement in the onCreate method. We change the tag from game to mainActivity.java and the message from surface created to onCreate. Then we can just copy the log statement and paste it in all the other methods. And remember to change the messages to the corresponding method names. Otherwise, you're signing up for some major confusion when you later on want to look at the messages in the logcat terminal. Let's run the app and try out the menu buttons. But before we press any buttons, we will look in the logcat terminal and see what method has been called. We see here that in the mainActivity.java class, we first called the onCreate method and then onStart and finally onResume. And after that, we see that some methods in the game.java class also was called, namely the surface created and surface changed methods. Now we will examine what happens when we press the app overview button, and we see in the logcat terminal window that the first method that was called was from the main activity class, and it was the onPause method. After that, the onStop method was called, and finally we see the surface destroyed was called in the game class, and then we get the same error message as usual. And as the final call, we see the onDestroy method getting called. And to make it easier to find the relevant messages you want to see in the logcat terminal, you can simply filter on some keywords. So since we name all tags with the class name followed by .java, we can filter by .java to only see messages that we care about, and we also see the error messages. You can also filter for debug in the drop-down menu to only display debug messages, that is, log statements that are written like log.d. Now we rerun the app again and press home button. Once more, we see that the same sequence of methods are called. We called onCreate, onStart, onResume, and also surface created and surface changed. But then, after hitting the home button, we call onPause, then surface destroyed, and finally onStop, before getting an error. Something that is very interesting in this sequence compared to the one we got when we pressed the app's overview button is that the onStop method was called after the surface destroyed was called. This could just be coincidental, and perhaps the execution order would be swapped if we tried again, but it doesn't really matter why the order changed. The conclusion is in either case that we somehow need to tell the game loop to stop calling the draw method already in the onPause method, since if we decide to do it in the onStop method, it would be too late and we would get the same error as we now see. We run the app one more time, and this time we click the triangle button. Also this time we get a slightly different execution order, but what's consistent is that the onPause method is called before the surface destroyed method. And now we are done experimenting and will instead try to prevent the app from crashing when the activity is paused. Let's go to the main activity and expand the onPause method. Before we make the super.onPause call, we want to call game.pause to pause our game. The field game does not yet exist, so we hit Alt plus return and create the field game and change the type to game. Then we can expand the onCreate method, and here we need to initialize the game object, so we type game equals new game and pass the game to the setContentView method. Nothing really changed for the setContentView method. We only managed to save the reference to the new game in the field so that we could use it in other places in our class. Now we can scroll down to the onPause method again, and we see that we still need to create the game.pause method, so we hit Alt plus return and create method pause in game. And what we really want to do in the pause method is to pause the game loop, so we write game loop.stop loop. Then we press Alt plus return and create the method stop loop in game loop. To understand what we want to do in the stop loop method, we can take a look in the start loop method and remind ourselves what is keeping the game loop running. We see here that we have a variable called isRunning that we set to true just before we call the parent's start method. And what's happening when we call a thread's start method is that it will run the code that's inside of the overridden run method. And if we take a look inside the run method, we see that the while loop, which is doing all the updating and drawing, will run as long as the isRunning variable is true. So you understand now how important it is to set it to true before calling this method. And maybe you've also figured out by now that to stop the loop, we would have to set the isRunning variable to false to break out of the loop and thus completing the run method call. So going back to the stop loop method, we can begin by setting the isRunning variable to false. And you might think that this is all that is needed, but that's actually not the case, and I will try to give you some intuition on why. If we start from when a menu button is pressed, we know that it would result in the onPause method getting called in the main activity, and from that method we are calling the pause method from the game class, which in turn is calling the game loop's stop loop method. And what happens when the stop loop method is called is that the isRunning variable is set to false, and then the method returns, which will trigger the game.pause method to return, which will make the onPause method also to return. And the problem here is that if the game class is really fast and calls the surface destroyed method before the game loop's run method has completed its current iteration, then we could end up in a situation where we once again try to draw something to a surface that doesn't exist. So to prohibit this from happening, we want to wait in the stop loop method for the run method to return. And the way to do this in Java is to call the method join, which is found inside of the thread class that is the parent to this class. This method must be encapsulated by a try catch block. So we write try, and in the body we write join, and then we catch an interrupted exception and print the error message to the stack trace. And to make it easier to examine when this method is called, we will add a log message with the gameloop.java tag, and we print the method's name as the message. We can then copy the message and also add it to the run method, where we just change the method name to run. And finally, we also add a log statement to the start loop method. Now we are ready to run the app again and see if we have solved our problem. If we look on the method call sequence, we can see that just after the surface is created, the game loop starts. Then we have a call to the surface changed method, and the run method is finally started. Now we try to press the app's overview button, and yes! Thank you mighty Lord! The app is not crashing anymore. Take a closer look now in the logcat terminal and marvel over the method calls. We first called onPause in the main activity, then stop loop from the game loop, and after that we called onStop in the main activity, and finally surface destroyed from the game class. And the cool thing now is that when we navigate back to the game, everything continues from the state we were in before pressing the square button. And in the logcat, we see that we, after returning to the app, called onStart and onResume in the main activity, and after that the surface was created, and then we called the start loop method. The surface is then changed and we start running the game loop again. Now we also tried the home button, and we can see that we now called onPause, stop loop, surface destroyed, and onStop. And finally, we tried the triangle button to navigate to the previous activity, and we see that this time we call onPause, stop loop, surface destroyed, onStop, and also onDestroy, which we didn't do in the other cases, which leads to an activity shutdown. If we were to open the app again, we see that the game is reset to its initial state, since we no longer see the game overtext. This behavior that the triangle button exhibits could be the behavior that you want it to have, but personally, I don't like it when I accidentally press the triangle button and I have to start all over with what I was doing. It could be that I'm playing a game or doing some online shopping, and I get so frustrated, for instance, when I'm writing a message and I accidentally close down an app and have to start all over again. So what we will do here is actually to disable this button. So let's head over to the main activity and hit Ctrl O to search for the overridable methods, and we can search for onBackPress. And here we simply need to comment out the super call to onBackPress to prevent any default backpress action. We can also add some logging to the method. Then we rerun the app, and now you can see that no matter how many times we press the triangle back button, nothing happens to the app. That was it for today, and I apologize a bit for making such a long video with so small code changes, but I was aiming for showing you how my actual thought process looked like when I was debugging this problem. And in the next episode, I have 2 alternative features I want to implement, and my default plan was to center the player in the middle of the screen, and instead of moving the player around the screen, we will actually move the world around the player based on how we steer our joystick. But lately, I've had some of you ask in the chat or comment section how to implement 2 joysticks in a game that can be controlled at the same time. After trying to implement those features, I realized when reading different forums that there is very limited information on how to actually make this double joystick work. So I think that it could be an interesting topic to show you, and I can show you how I ended up solving this issue, even if I don't really know if we need another joystick in this game. Maybe we could use it to change the direction in which the player is looking, so we can control in what direction we shoot our spells. Let me know in the comment section which feature you prefer me to implement first, and if you are very fast to write, I will take that into consideration before making the next episode. Bye everyone, and don't forget to like and subscribe.